Hello and welcome to the last talk of today. Here we have Christopher Neugebauer, Java for Python developers. So Chris is an Australian programmer who lives further south than Wellington. Yeah, Tassie represent. He currently works as an Android developer, which means his day job involves a lot more Java than he would like. His main interest in Python has become community development and he is the immediate past convener of PyCon AU 2012 and 2013. He's also on the Linux Council Australia board. And yeah, he's a fellow of the Python Software Foundation since 2013. So please welcome Chris.
Thank you so much for that introduction. So yeah, this talk is called Java for Python Developers. And so before I begin, I'd like to sort of warn you about the contents of this talk. We're at a PyCon, but we're going to be looking at interoperating with real code written by people who use other languages in the real world. And as a Python developer, what you're going to see on the next few slides will probably be entirely disturbing. There are people in this world who think that it's perfectly reasonable that there are languages where this is the shortest possible way to write hello world. And I know what you're thinking. There's so many words here. What does public static void main string args even mean? And why should you care? There's no way in the world that this could be a short program. And because we're here at a PyCon, well, we know that there's a better way, and it's probably 119 characters shorter. Or if you're using Python 3, you just add some brackets. We're happy. Unfortunately, there are people out there who tend to like Java, and they're people who make important decisions. Java is quite popular out there in the business world, and quite often, even if we want to replace Java systems, Java is far too entrenched to have any hope of swapping over to a more reasonable language like Python. And there's one company in particular that likes Python a lot, or is known to like Python a lot, but they like Java a lot more in actuality. I'm not going to name any names, but we'll get back to this company later on. So the hope with today's talk is that you'll find out about some tools that you can use when you have no choice but to enter the world of Java, but still retain your sanity as a Python developer. So let's start off by defining what Java is, because you've probably heard of the thing, but it is the topic of this talk, so we should actually give you a clear idea of what I'm talking about. So Java is well defined as three separate things. The first thing is the Java Virtual Machine, or JVM. That's basically the core virtual machine that your applications run on. Then there's the Java programming language, which is what you write your own code in. And then you have a thing called a class library. If you've heard of Enterprise Java or Java Mobile Edition, the difference between these and Java Standard Edition is what you have available to you in your class library. Now, when you write a Java application, you will write your code in Java the language, and you use the Java compiler to produce JVM bytecode. And this JVM bytecode gets run on the Java virtual machine. So sometimes you need to access some code that comes from another source, such as the Java class library, such as third-party code that's distributed by someone else. When you want to run that code, the JVM just loads it from your disk at will. Linking on Java, the platform, is purely lazy. It's entirely dynamic. So what are the options for running Python code on Java, the platform? So you have Java that takes source code, translates it into bytecode, and it runs that bytecode on a virtual machine. In the classic CPython environment, things are basically the same. You have a virtual machine, it executes some bytecode, and library code is lazily loaded off disk. The main difference is that there's no separate build phase. So bytecode tends to get created when you first import a file. The Python VM itself compiles that module and it spits out a PYC file that you can use into the future. So there's this thing called Jython. It's been around since about 1998. It's a version of Python. It's written entirely in Java and it runs entirely on the JVM. It has a specific goal of aiming towards CPython compatibility for a particular version of CPython. And a very specific goal of theirs is to be able to run any pure Python library that CPython can run. So in the case of CPython, you produce PYC files when you import a file, a module that you want to run. In the case of Jython, it produces JVM bytecode when you import a Python file. So it can dynamically load classes as it needs to, and it can interoperate entirely with Java classes when you need it to, including subclassing Java classes and implementing Java interfaces. So it's written in Java, it runs on the JVM, it compiles to Java classes, and it also has a whole bunch of really useful tools. Like it has setup tool support, which can produce precompiled jars containing your Python applications, so you can import them from other Java applications, which is really cool. Has a REPL that you can use, just like CPython. But as you can see, you've got full access to the classes that your Java environment has. So this is importing the system class from Java and using that to print out hello world. So it's basically exactly the same as calling system.out.println from within Java the language. But most of the standard trimmings of Python are there as well. And indeed, if you want to maintain compatibility with CPython as much as possible, using Python standard calls makes a lot of sense. Jython development slowed down for quite a bit. The last stable version was released in August 2012 and targets Python 2.5. They've been aiming for Python 2.7 support since then, and they're just about at release candidate stage for Python 2.7. The latest beta now supports requests, so most of the HTTP networking type stuff that you want to do from within Python, you can do within Jython. So Jython's good. Basically, anything you'd want to be able to do in Java the language on the JVM, you can do within Python using Jython. And most of the things that you'd want to do in CPython 2.7, you can now do on the JVM. But we have this thing called Android, and Android's a really interesting and important use case for Java the language. Android's important. It holds about 75% of the world's smartphone market at the moment. And last year, in 2012, Android devices alone outsold full-size computers for end users, like on a twofold basis. So Android's basically the largest user base for the largest type of computing that end users use at the moment. And as you would probably have guessed, Android is programmed with Java. But what do I mean when I say it's programmed with Java? Because it actually isn't strictly speaking Java. As a developer, for the most part, you don't care that it's not actually Java the platform. You write your code in Java, you use the Java compiler, and you get access to something that resembles the standard edition Java library. But what differs is the runtime. Android uses what I'm going to call the Dalvik model. This uses a special virtual machine called Dalvik, which is almost but not quite entirely unlike the JVM. Now, you've probably heard of this thing called ART, or the Android runtime. This is a drop-in replacement for Dalvik, but the distinction really isn't that important for us as developers, so I'm not going to talk about it anymore other than this lip service I've given you. Where I say Dalvik, you can say ART instead. It's basically the same as far as we're concerned as Python people. So, to recap, this is how a JVM application works. You execute JVM bytecode that you've compiled from Java source, or perhaps from Jython source and you've imported it. External libraries are loaded from class files as needs be. Now on Android, this lifecycle looks slightly different. There's an extra step. Once you have your JVM bytecode, it gets translated into a thing called a Dalvik executable. And this Dalvik executable runs on the Dalvik virtual machine. But you've probably noticed something missing from this diagram. Where do you get your third-party code from? Where does that exist? It doesn't get loaded in the same way as it does in the JVM. Let's look inside a Dalvik executable. Inside it is your own compiled Java code, but this executable bundle also contains all of the third-party code that you need to run your application. It basically gets merged down into a single file, so there's no dynamic loading of external classes. All the classes that you use in an Android application are statically linked at build time. So when you're writing an Android application, you have access to whatever you have had at build time, or you have access to nothing. And what this means is that the entire premise under which Jython works is completely inapplicable on Android. because you can't spit out a Java class file and have it available to your Java environment. So with Dalvik's almost but not quite Java model for doing things, we need to find an alternative solution. So what else could work here? So we know that CPython works pretty well, and it's had a fully fledged C extensions API for a very long time. So if you're unfamiliar with it, basically how this works is you write a C program that you compile with your C compiler, and it produces a library that your CPython environment can load, and that can call off to any C library that exists on your system. Likewise, Java has a C API. And unlike everything else in the Java environment, Android actually kept the C extensions API entirely wholesale. So it's all there. So Java's C interface is called the Java Native Interface, or JNI for short. So the idea is that you can write a C extension that contains bridge code that calls JVM methods that can call into the bits of the Java interface that you care about. So basically you get access to anything that is written in Java on your system's Java environment, or your system's Dalvik environment if you're using Android. So the problem with the JNI is that it's actually quite complicated to write. This function here takes a string from Java and it prints it out using C++'s standard cout method. So for a function that just takes a string and echoes it to the screen, this is stupidly complicated. You have to get this method name exactly right, and you have to match it up in your Java code. Getting variables out of Javaland has a really complex API, and you have to manually manage your memory objects, your Java objects, from within C. So if you have a code base of any degree of complexity, it's basically impossible to get this right and maintain it. In particular, if you refactor your Java code, or the interface to your Java library changes, your C method names might be wrong. So basically, the JNI is a horrible mess to actually use. You lose the benefits of both Java and C. Yes, Java has benefits, and you lose them when you use the JNI. So basically, if you're seriously considering handwriting your interface code using the JNI, you're certifiably insane. So what's the solution? Well, the solution is to get a tool that does all the heavy lifting for you, to bridge the two languages. So you've probably heard of a project called Kiwi. It's a project that's aiming towards producing a touch UI library that's written entirely in Python, so you basically write your touch applications in Python instead of in Java or Objective-C or whatever. And you can make quite complex apps with it. This is Process Craft. It's the application that you're mandatorily required to display when you're talking about Kiwi in a conference. It's quite a complicated application. It sells for a lot of money, and it's written entirely in Python using Kiwi as the UI toolkit. Now, when Kiwi started off, there was absolutely no way to deploy Python to Android. So they have a second project called Python for Android. It's a project for getting Python to run on Android. And Python for Android consists of three key parts as far as we're concerned. The first is a CPython framework for Android, so you can run Python code on your device. There's tools for packaging and deployment, so you can get your Python applications running on Android. And a third thing, which I'm going to talk a bit more about, called PyGenius. PyGenius is a library for dealing with the complicated bridging between Java and CPython. And this is Hello World in PyGenius. You can see that at the end we're calling Java's printline method. And there's the boilerplate for it. Basically, all you need to do is import this auto class thing from the Genius library. Auto class wraps any available Java class to your current Java environment into a Python class. You can then call Java methods and access Java attributes just as though they're native Python calls. So it's pretty cool. Just to show you what's going on under the hood here, once you've called auto class, Genius takes care of wrapping all the Java attributes and methods. So system is actually a Python object which represents the Java class, and system.out is a wrapped thing that wraps the specific Java print stream instance that system contains, and system.out.println is a Python wrapper for a Java method. Basically, it takes care of proxying your Python calls into Java calls and vice versa. So there are many cases in Kiwi and other consumption-based APIs where what I've just shown you is enough. You just wrap a class and you can use its attributes straight away. And that's good for quite a lot of cases where you want to drive the JVM from within Python. But if you want to deal with things like callbacks or implementing interfaces that are required, that's not quite enough yet. But PyGenius can help with that as well. So here's a really boring piece of Java code. It's a class, it has a method called runThis. You pass in a runnable object, which has a run method on it, and you basically call that run method on the runnable that you pass in. It's not terribly interesting, but it should prove something, hopefully. Here's a simple Java program that drives that previous class. We have a runnable class. All it does is print the string hi from Java. And then there's some code that instantiates it, passes it into our PyRunner thing, and runs it. And it does exactly what you'd expect. So that's implementing a program that uses that class in Java. Now here's a Python class. It's got a method called run on it, and a bunch of other decorators and annotations. Now hopefully that gives you some sort of clue about what's about to go on. Here's a bit more of a clue. Our class derives from Python Java class. It has a slot called Java interfaces, and it has that decorator above the run method called Java method. And there's a class and there's a program that drives it. We use autoclass to wrap the thing that we wrote earlier. We create an instance of it, and then we basically pass our Python runnable thing into our PyRunner, and it runs. So it's basically taking a Python class, passing it into a JVM object, and having the JVM object go back and execute our Python class, all from within CPython. So in summary, PyGenius lets you script Java objects from CPython. It's close to feature complete if you're using Java objects in a consumption-only fashion, and it's also good for creating callbacks from Java code into Python code. And best of all, because CPython runs well on Android now and the JNI is properly implemented on Android, PyGenius works on Android just as you would expect. You can consume Android API objects as you need to, and where they need to provide listener interfaces, you can implement them in Python. So this means for things like accelerometer access on Android, which requires you to specify a callback object, you can do this entirely within Python. So unfortunately, whilst PyGenius is good at bridging things, it's not quite complete yet. When I tried to write the example code for this slides, I tried to basically have it create a Java thread from within Python and execute our runnable from within a Java thread. And there's various bugs in that. Despite how I massaged my own code from within Python, I couldn't get Java threads to execute our Python runnable. There's also massive usability bugs at the moment. If you remember this Java method decorator that I showed you earlier, we have to provide this weird string here, this bracket v thing. This is called a JNI method signature. The JNI uses this string to figure out what method to call from your C code. So this one is for a method that takes no arguments and returns void. This is literally the most simple JNI method signature you can come up with. If you have something that's even slightly more complicated, like this one which returns a collection and takes a string, a long, and a boolean as arguments, this has a method signature that looks like that. And as you can see, this is pretty much unusable. There's no good reason why a Python programmer should have to learn how this works, and yet PyGenius relies on it to implement interfaces. And If you're trying to make some code that's going to last, these are also a documentation liability because it means that anybody who writes your code also needs to know how JNI method signatures work. So a Python API for actually writing signatures is close to essential. The next problem is that PyGenius won't subclass Java objects. Now, as Python programmers, we don't really care about the distinction between implementing an abstract base class versus subclassing an object. There's basically no distinction between these things as far as Python programmers are concerned. But Java does make a big distinction between these, and they all have semantic differences. And they all use completely different mechanisms under the hood. So Java has 3 different types or classes of type that you can implement in Java the language. There are interfaces, which are basically classes that have no method implementations whatsoever. They just define a protocol. Abstract classes, which are classes which leave some of the methods unimplemented for the implementer to come and write. And concrete classes, which are classes where all of the final methods are in place. Now currently, PyGenius only lets you implement interfaces. Unfortunately, most frameworks, Android included, require you to override abstract or concrete classes to fully use them. This means that you can't currently implement an entire Android application from within Python using PyGenius. That said, most of these bugs can be fixed in a way, and when they are, it's probably going to be the best shot towards producing a native Python API within Android. So I've shown you 2 tools for using Java and Python in the same application. The first being Jython, the second being PyGenius. And this demands the question, which of the 2 you should use? Well, if you need to add Python scripting to a Java program, or if your requirements require extensive JVM use, basically if Python is peripheral to your greater goal, you should use Jython. If you need complete JVM access and all your code runs on the JVM, or you use Jython. The downside is that you only get experimental Python 2.7 support, and support for C extensions is not likely to work out of the box. It works in some cases, but not all. If your use of the JVM is incidental compared with your use of Python, or if you need your stuff to run on Android, then PyGenius is probably your tool. You get all the goodness of CPython at the trade-off of having to use reflection and proxy objects to cross the JNI bridge. It also has a few bugs, both functionally and in terms of usability. So that's basically the end of the talk. So to summarize, when we talk about Java, we're talking about the combination of a language, a runtime platform, and an API. Unfortunately, the distinction is quite important. Jython is getting active development again. Python 2.7 will almost be supported in a stable release, probably by the end of this year. But the interesting case, as far as I'm concerned, being Android doesn't match our understanding of Java nearly enough to make Jython work. PyGenius is doing a good job of bridging the gap here, but it still needs some work. So that is the end of the talk. Thank you very much. And are there any questions? So Eloise, if you can start off with Nick.
Thanks for that, very cool. With the running Jython index files, do you know if anyone's experimented with the pre-compilation support for Jython?
So I tried to play around with Jython on Android late last year when I was researching another talk. Jython itself will load, but the moment you try to import anything at all, it doesn't work. I don't know why that is, but you'll see a whole pile of GitHub. You'll see a whole pile of GitHub attempts to make Jython run on Android, and they'll have 4 commits. So everybody's run into exactly the same issues. Now I know that Clamp, as part of the Jython 2.7 effort, is producing tools that allow you to define a Java class externally, such that basically you can run the jar and it will go straight into your Python class and requires Jython as the runtime. I haven't seen any experiments with that It seems like it would probably have a better chance of working than Jython has in the past, but I haven't played around with it. It's something I didn't get around to for this talk.
Hi, thanks for the talk. A while back I had a chance to introduce Python into an organization which was mostly using Java. And so Jython worked great because all the classes and everything was instantly usable. And what you discover along the way is that the Jython, when it comes to, for example, numerical loops and those sort of things, is actually faster than native Python because the JVM is fantastically optimized.
Yeah,
and no
just-in-time compilation and no GIL.
No GIL. So if you have multi-threaded applications on with lots of cores, it's awesome. Even if you don't need Java for anything, if you have multi-threaded Python, the Jython might be something to look at.
So this is something that Guido would always say back in like the early part of last decade, which is like, if you've got an issue with the GIL and you need high-speed Python code, just use Jython. The problem is, of course, that the last stable version is Python 2.5, which stopped being the recent CPython version in, 2008. And Python 2.7 support is still not stable 4 years after CPython 2.7 came out. That said, if you're happy with if you're happy with Python 2.7 and you're happy with experimental support, go ahead and use it. It's pretty good. And you won't get a GIL, and you'll get just-in-time compilation. But I think Nick has something to touch on that. Can you just pass the mic to him, and then I'll get to your question.
The other fun compatibility issue that can come up with both Jython and IronPython is they have 16-bit strings, even in Python 2. So code that is Python 3 compatible is far more likely to work with them.
Even though you can't get Python 3 in Jython yet.
I can't remember. Can you maybe give us an idea who's actually really behind development of Jython, and how likely is it that it's going to continue to be developed and maybe even catch up?
So if I recall correctly, the last commercial development on Jython was sponsored by Sun Microsystems, probably in 2005, 2006.
At Cody and the currently sponsoring Frank.
Oh, so actually it's still corporate sponsored now. Okay, that's interesting. I was under the impression that it had gone to community development since then. But if they've finally got some money behind it, that's good. Because it wasn't for a while, if I recall.
I think it's still I think it's a case of they're using it, and so
Yeah,
actually.
I get the idea that the support's very recent though, because it took a long time for their Python 2.7 effort to actually start getting any traction. They started in 2012, only just started getting it to the point where it works. Oren.
Hi.
I think you might have just switched it off.
When you guys use the mic, just switch it to mute. Don't turn it off.
Put it on mute, you say.
No, turn off mute.
Okay, it's on now. Okay,
Yeah.
Here we go. Yay, you can hear me. Hi, thanks. That was really interesting. Thank you.
Cool.
With PyGenius, what kind of performance penalty are you looking at while you're crossing the bridge?
So I haven't actually measured it with PyGenius. My day job involves a lot of JNI on Android stuff, and the actual cost of wrapping just on the JVM side, wrapping a C++ object to be called from Java is basically negligible. So whatever the performance penalty of hitting the of hitting the CPython extensions API is would be whatever your performance penalty is. And I get the idea it's not very much. Nick doesn't know he's a CPython developer here, but it's negligible on the Java side.
I'm hoping this isn't a stupid question, but in terms of solving the Jython problem on Android, if all of your Java libraries are actually open source libraries, is it possible you could import all of that source code into your project and compile it all together, and wouldn't that solve the problem?
Yes, but if you're in the case that the code is written in Java, that's basically what you already do. In the case of your code being written in Python, you still need the Jython runtime. We've got one down here.
Thank you. A while back, I experimented a bit with Kiwi. It was really nice, but I think what you find is that it's not. It doesn't have a very native look and feel to it. So, do you know if they are doing any work on making it possible to write more native-looking applications?
So they think they are, but they don't know what they're talking about.
Okay.
I had this discussion with them after I gave a talk which said very terrible things about Kiwi last year for that particular reason. I write native Android applications in Java in my day job, and I'd very much like to be writing Python, but there's not really any effort in terms of getting the remainder of the framework support using PyGenius. I do have some ideas on how to make that work. I just haven't had the spare time to write them down. But I think there is a way to actually get to the Android API reliably from within Python. And if you can do that, then you can basically write an entire Android application from within Python, and that would be a great end goal, because then you can basically make a usable API around that from Python. Once you have the Java support in there, then you can go and make it useful. And Nick has something to comment on there as well, so I think that will probably...
Just Toga.
Oh, go ahead.
A project launched at PyCon Australia was Russell Keith McGee's Toga project, which is aimed at specifically that problem that Kiwi uses theming on the mobile platforms, and Toga aims to use the native APIs of the mobile operating system.
And it currently has 0 Android support because it's such a difficult problem.
But it's aimed at that.
Yes, Toga is definitely aimed at that. It looks like a good effort towards writing UI code from within Python in a purely Python sense, but I think it's going to be a difficult problem to solve on Android without solving the problems that I've discussed here, just because Java interop is considerably harder than interop with Objective-C.
I think that's all we have time for. If you have any more questions for Chris, please feel free to harass him at the dinner, or he'll be here tomorrow as well. Now would you please join me in thanking Chris for his talk?
Thank you so much.